In the fall semester statistics class at Seaholm High School, students have two opportunities to experience a real-world application: Statistical Process Control, or SPC. The first project, manufacturing precision 3D puzzle pieces, offers a straightforward example of the necessity of stringent quality control. Later in the semester, students construct a 50-link chain of identical plastic links, each of which has to pass several rigorous quality checks to enable all the pieces to interlock successfully. Two production projects are done in conjunction with the industrial technology students. Advanced automation robotics students design and build the jigs and fixtures needed for each project. Several students are enrolled in both the mathematics department's probability and descriptive statistics course and the industrial technology department's automation robotics class. But this is not a requirement for taking either course. The dual-enrolled students gain a unique understanding of how each field contributes to the other and serve as team leaders in each course. Before production started, these dual-enrolled students explained to their classmates how to perform the tasks at each station. Precision measuring is a crucial component of using statistical process control. The students designed this device with a removable top plate so that it could be adapted for use in both production processes. Named Stonehenge, this was an example of both the students' creativity and ingenuity in problem solving. The pieces were carefully cut and measured. The length and each of the 4-angle measurements were recorded on separate control charts. The workers could tell immediately that the pieces were good quality because the measurements were within the control limits. The finished piece will have 4 angles and each must be perfect so the finished tetrahedron will fit together smoothly without any ridges on the sides. Students knew that it was important to do each step of the process very carefully for each piece. After the project was completed, students used industrial application SPC computer software to further analyze the data and see where they can improve the process. A 50-link floating plastic chain was the second project. 3 separate pieces had to be precisely cut and drilled so that the links could fit together smoothly.
What we're doing here is we're drilling the holes for the spacers, or the rods that go in between the two pieces. And what we have is, if you want to do that first thing.
Sure, okay.
We put the part just in here, and first we raise up a stop right there, and that'll stop the part. And then we have a clamp that'll clamp the part. Normally stops back here in the piece, and then we just feed the drill bit into it. And then we back off on the clamp. We lower the backstop, then we clamp it again. And the second time we clamp it, it feeds all the way to here, and it drills a second hole. And these have all been figured out so that their exact spaces, the measurements have already been pre-done. And we just have a hose here for cleaning off, keeping the jig clean so there's reduces the amount of variation. There's the backstop up, and then we'll clamp it. Use the mill, make a cut. Give it clamped. Feed it out. On.
Here is I'm measuring the pieces after they're cut as to if they fit on the fixture. And this one does fit, so we know it's good. And then we try the next one, which is 204, and that fits perfectly, so we know that fixture was done right. 205 is not good. We can see that this was a human error, so we're going to reject this and we're going to put it in a different pile, separating it from the good ones. And then 206 works perfectly, and 207 also works perfectly. It passes right over the fixture. Know that 205 there was a human error and that the holes were drilled wrong.
Are they in control, out of control?
And so we're putting it into a different pile here to separate the good ones from the bad ones.
From the go, no-go gauge, we take the parts over to the sander to round the edges off here. And we'll take all the parts over that are in the good pile and we'll run those. But this piece 205 that Pete put in the go, no gauge that was a no-go is a waste because it doesn't even fit on the piece here. It doesn't reach the other hole. So we won't even bother running that piece. We'll just put it aside and we'll go with the other 4 here. So over to the sander we will go. We'll place this onto the sander. We'll place the piece on top, just similar to how Pete put it in the go-no gauge. Put it on there. Start the sander. And we'll round the corner off. Here we go. Just like that. Take it out, flip it over, and go with the other side. Right around. And there we are with piece 206 with its rounded corners.
Labels were applied to the pieces as they were cut to the exact specifications. This was done so that the measurements could be accurately recorded and that pieces could be tracked if necessary. Vernier calipers were used to measure the lengths of the spacer tubes and the pin rods. Precision is necessary for these parts so that the finished chain can be flexible but not floppy. Each piece's measurement is recorded on the appropriate control chart.
In this process, this was designed so that each of these pieces, as you can see, they alternate gray, yellow, and they are put on in a fairly random order. But in our process, we allowed for this to happen because our variance, which we did have, was very small, but yet it allowed for a flexible chain.
Also, with our chain here, we alternate the yellow and gray, and there's a significance to this alternation. The yellow pieces came from one machine, and the gray pieces came from a totally different machine. And even though they were produced on 2 different machines, they conform to the standards that we have set and are similar enough to each other that we can have both pieces in the same chain working and being flexible, creating a quality product. Smythe?
An advantage to using SPC in a process similar to this in the real world situations and in building a chain like we did, you have a lower variance among pieces. Like Albie said, you have more interchangeable between parts, and you can see that this chain is extremely flexible. It works quite well. We were measuring some of the pieces within thousandths or even 10,000ths of an inch for a piece that really was not precision to begin with, and it did turn out extremely well.